these next couple of questions still follow along the same lines. So Alfonso earned a score of 85% on his test. He did 34 problems correctly. How many problems were on the test? So let's do our R, B, and P again. So we do have a percent in this one, so that is likely our R. So he did 34 problems correctly. How many problems were on the test? So again, you got a 50-50 shot of where this 34 goes. It's either going to have to be the base or it's going to have to be the part. Now, if he did 34 problems correctly, how many problems were on the test? So hopefully there was more questions on the test than there were he got right. So the base in this case has to be bigger than the number of questions that he got right. So the 34 problems, if you think it through, it has to be the part. So the base is what we don't know. So in this case, if we divide P over B, and then we change it to a decimal, so we got a bit of a glare there. 34 divided by let's turn it on and clear it. How about we do 34 divided by 0.85. Let's see what we get. We get 40, which makes sense. There's 40 questions on the test. I mean, what's nice is that you can try it the other way pretty fast and see that it doesn't make sense. So if we said that the base was 34 and the part we didn't know, the process would have been to have multiplied them. And I'll just cut to the chase. We multiply by 0.85, we get 28.9. So now does that make sense? If there was 34 questions you got right, there was only 29 questions on the test. That doesn't make a lot of sense. So there was 40 questions on the test. And like I said, a real quick double check, and you can always confirm that your answer makes sense. So let's try the last one. Now, don't mind the red marks. It's just little edits for myself. An ad for steel-belted radial tires promises 15% better gas mileage. If Sheena's SUV has gotten 20.6 miles per gallon in the past, what mileage can she expect after her new tires are installed? Round to the nearest tenth of a mile. All right, so start off the same way. Looks like that 15% is going to have to be our R. So now, same question again. Where does that 20.6 go? Is that the base or is that the part? Now this one is tricky because of the way it's framed. You're thinking that you should get a better gas mileage as your final answer. But it turns out 20.6 is going to be the base. And I'll show you why. So if we do our percent equation formula and multiply, and I'll start cutting to the chase a little bit. 20.6 times 0.15, we get 3.09, which is pretty close to 3.1. Now wait a minute, you're saying, well, how could it be 3.1 be the answer? Well, it's not. The question says that it promises 15% better than what you're already getting. So 15% better than what you're already getting, you have to add your new additional mileage onto what you're already getting. So the new mileage is going to be equal to the old mileage plus the better mileage. So that's going to give you 23.7 miles per gallon. Now, just in case you were curious what happened the other way, let's see what happens if you reverse the two. So if you got R is 15, you got the base is unknown, and then you got the part is 20.6, well, we would have had to divide. So 20.6 divided by 0.15. So 137.3. So that would have been the new mileage, or the better mileage. So if you get a tire that gets 137.3 miles per gallon, I would buy it. So that is likely not going to work. Now it is confusing because you got that 3.1 and it seems awfully small, but you had to add that to what was existing. So, okay, so let's stop there and then we'll tackle those last two questions, which is a slight twist on the process.